I have a little video here. I'm going to call it The Sound of Science. So, this is extracurricular, piece of nonsense, nothing you actually need to worry about or know. So, let's get started. The science of sound, the sound of science. One wave cycle, a wavelength, you'll have heard of that. This is to do with the pitch of the sound. So they all have different wave cycles, which is vibrations per second. The sound vibrates air molecules, it moves things in your ears, it affects things, it shakes the air. So the frequency of a sound wave, frequency is how low or high. This gives the sound its pitch, and all frequency means is how often something happens. That's it. So we talk about cycles per second. So if this was 100th of a second, there's about 4 of them here, so you would have 400 per second. So we measure this in hertz. So this wavelength here, if this was about 100ths of a second that time was going along here, then this would be around 400 hertz, which is actually around here. So time goes this way if you were drawing it as a graph, and this is amplitude. This is the volume, this is how loud it is. So if it's a little low squiggle, it'll be like, and if it's a big tall one, it'll get louder. So let's say our wave here is the sound from A4. That's the A on the piano, just below middle C. So what would the next A look like? The A5. You can see there's more squiggles, more humps, there is more cycles per second. So you see the wavelength in green of the A4 down here, and then the wavelength in red I've drew of A5 up here, and you will see that it is half the size, so you get twice as many of those. So 1 octave, these all squish up, you get twice as many per unit of time. Just clearing it all away. So a wavelength, I should have said, I'll draw a wavelength. Basically a wavelength goes up, down and back up, or it goes down, up and back down, but it starts and ends in the same place. So that would be one cycle, one wavelength. And if it was along here, it would be basically the second, you cross the middle. So that is how we measure a wavelength, and how many of those per unit of time is how we measure frequency. So normally wavelengths per second, cycles per second. So take that away. So if this was a lower A, then the higher one has more squiggles, And if we went up again, you get more cycles per second. It doubles each time. The wavelength gets half the size. Oh. I pressed the button on the piano. So that's increase in frequency. So if you played 3 notes at once, that are each an octave apart, this is what the pattern would look like. You see 3 wavelengths. Each one is double that. Well, you see 3 waves and each one is twice the frequency of the one before. So if it gets louder, we go up, taller, amplitude. And this is completely extracurricular. This is just because I like science, but I think it helps you appreciate music more if you understand the science behind it, how music is affecting your ears, the universe, the air, the everything. So here's where frequencies going down, lower notes. You get less cycles per second. They go very slow. And then if the frequency is going up, so A3, 220 Hz, A4, 440 Hz, A5, 880 Hz. So there is actually a maths formula that tells us the frequency of any of the 88 keys on a piano. If you pick any key. So you can say that again. So any key, if you numbered them 1 to 88, so we'll call the number of the key n, and this formula will work for any key on the piano. So the frequency, pitch of key n equals 440 multiplied by 2 to the power of n minus 49 over 12. So if that makes no sense to you, it doesn't matter. So say key 59, the 59th key in the piano, which is G5. So it's 440 multiplied by 2 to the power something. So the something is n minus 49 all divided by 12. So if n is 59, 59 minus 49 makes 10. So 10 divided by 12. So it's 440 multiplied by 2 to the power 10 over 12 actually gives us the frequency of this key, and it works for any key on the piano if you number them all 1 to 88. So the frequency of key 59 is 440 times 1.78 blah 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 blah. So that becomes to about 784 Hertz. And it would work the same if you wanted to know, I mean, sit and count them. Say 2. Well, there's key 5. So 5 minus 49, that would make minus 44. So it would be 2 to the power minus 44 divided by 12. And then you multiply that by your 440, and that would literally give you the frequency in hertz. So that is just an extra piece of nonsense that you don't need, just because I like science and I like math. I like the way everything just works out, logical. Music can be drawn. So, as I said, a fun insight into what music actually is, the physics and the maths of sound waves, volume and pitch and vibrations and cycles, and how it all relates to each other and how it's represented in graphs. So there is a big low sound, there's a higher sound up there. So I'm just playing with some graphs here. Yep. So when you start to put all the stuff together, rather than just, you know, one note at a time, you start to mix waves, making patterns, because each key on the piano, you'll see, makes a different kind of wave. So they're not all exactly doubles and halves of each other, there's everything in between as well. So there's a kind of science behind notes being in harmony or not in harmony. So just going over pitch and volume here. Now the thing to notice about the amplitude is the width of the humps here, the wavelengths, the cycles stay the same. It's the up and down that increases. If you're keeping the pitches the same and you're just turning your volume knob up and down, it moves like that, it stays within its same frequency. So then if we start to mix sounds, you get all sorts of nice patterns, and there's a science behind whether sounds sound happy or sad or harmonious or dreadful. And I don't know the science. I can't sit and go into all the maths and science of how it all fits together. Press the bottom button again. So basically this is how sound fits together into nice patterns, and I hope that this gives you some sort of appreciation of what sound is and motivates you to study music at a deeper level. So if you've got any suggestions for stuff you want me to do, you can email bella@bellapiano.co.uk. So like my videos and subscribe to my channel. Thanks for watching Bella Piano.